good afternoon and thanks for joining us. My name's Brendan Bouffler. I lead a bunch of folks in the scientific computing organisation at Amazon. So we're here today to talk about the spot market, in particular about how some of our scientific users are using it to some pretty good advantage. So, whoa, a bit of feedback there. So first, just to give you some background, there's some really serious uses for this stuff. Something we're particularly excited about that for our customer here at the show today is that NASA's been able to win an award for the best HPC collaboration between industry and government for a workload that they've done to count the biomass in Sahara, the South Saharan desert part of Africa, as a way of actually forwarding a lot of their research associated with climate change. So, really cool project. It's a project that's been done with Scico Computing. We're kind of very thankful for Scico Computing for offering us a second home here at the show today as well. So the group that I'm part of, we look after our science customers, and our mission is to make sure that the cloud's relevant to our science customers, and that we keep coming up with new features, useful features in the cloud around science. But our particularly big think objective is to democratize costs for all those science users out there, and to really have a very disruptive impact on the way that people are doing scientific computing. We want to change the way that scientists compute in a really big way. So we have a global infrastructure. We've got 11 regions around the world. A region for us is a cluster of availability zones, and inside those AZs is a cluster of data centers. And then typically in those data centers we might have between, say, 40, 50, 80,000 servers. So it gives you an idea of the scale that we operate at, and it's an enormous piece of infrastructure. We've just actually announced some new regions that are coming in 2016 in the UK and in India, South Korea, and another one here in the US in Ohio. So that actually extends all of that out, and we'll get out to 15 regions by the end of next year. When we have all that global infrastructure, one of the cloud model that I'm sure that a lot of folks are going to understand here is the cloud model is one where you pay for what you use. And the corollary of that, or the obverse of that, is you don't pay for what you don't use. And that's actually pretty significant because it gives you a bunch of opportunities to save a lot of money. Most importantly, one of the things that the cloud model allows you to do is to burst into pretty high size workloads when you need it, right? So you don't have to own that bit of infrastructure. The really big power of the cloud model comes when we share the infrastructure amongst everybody, and everybody just pays for their piece. In order to maintain like a really big piece of global infrastructure like this though, and so that we can always say yes to a customer who comes along, especially a customer who might want to do a really peaky workload like this where they expand a significant portion above their normal baseline, we actually have to maintain quite a bit of overhead in our data centers, right? We need a lot of extra cores that people can grow into, if and as and when they want to. So, in the worst possible case, that this bit of additional overhead may actually turn into like a cost that sinks into everybody's bill, and actually essentially raises everybody's bill. Everybody's paying for this spare capacity, and that actually is not a principle that we support. So, in a very Amazonian way, we came up with a thing called the spot market, which is really our auction market. It's an eBay for CPU cycles, as it were. So what we do, we're essentially monetizing that overhead. We're giving everybody access to this at really low rates. They bid for what they're willing to pay, not what the sticker price is. And you get allocated a bunch of resources for a short amount of time, for like an hour or 2 hours, or in fact, however long your bid is in the market, as we say. And this is a really amazing way of getting access to a really, really large amount of resources at a very low cost, and it's very flexible. So we're making a lot of use of the spot market, and this is pretty popular in science, as you might imagine, because us scientists are cheap. So it's a great way of putting resources in the hands of folks. We've got a lot of customers, who are accessing petaclass scale core counts for hundreds of bucks, right? And so that's a really interesting workload. So what this does is it gives us three different ways of people buying core hours or getting access to core hours. They can either buy it as the on-demand prices, and that's great for short-term workloads, that for small workloads as well. if you've got longer term usage, you get into the reserved instance purchasing model, and that's interesting to a lot of folks because it's essentially buying in bulk. And if you've got long-term persistent services that you need to run, like a database or a mail server, some enterprise workload, then that's actually really a perfect platform for you. And then what's actually more interesting in the science cases, in the research computing cases, is Spot, right? And again, we typically see, when we look at the spot market, we're typically seeing people getting access to cores for, anywhere to like 85 or 90% off the sticker price. Right, so it really is a way of getting access to cheap stuff at a very large scale, very easily. So one of the caveat with the spot market is, if you're in the spot market and you've got an instance running in the spot market, it's a normal instance. It behaves exactly the way you would normally expect it to do. But there is a caveat, which is that if a full price paying customer comes along and wants to use some stuff in the cloud, they're the reason that we had that overhead there to begin with. We'll look for somebody to take out and to shut down in order to make room for that customer. And that is the caveat that comes with the spot market. Now, for a lot of science workloads, that's actually perfectly acceptable. If, all that really means is that in a lot of workload cases, it means your job may not get run for another hour. It may take another hour to get your task complete. In a lot of science workload cases, particularly in research computing, no one's going to die if your job actually gets rescheduled for another hour or two. Right, so this is actually an acceptable caveat to put up with. Now, so last year there was a company that was a customer of ours. They're a small analytical company. They were using machine learning algorithms to game our spot market and to study our spot market and to forecast what its behavior was going to be in the next few hours or the next few days. And they were using machine learning algorithms to actually do that behavior prediction. That gave them an ability to actually schedule things and to have a price bidding strategy in this market that gave their customers a huge advantage. They would get access to these cores really, really cheaply, but they could maintain a persistent service and actually ensure that the customer's workload never actually got knocked out or got rescheduled. So we thought they were doing such a cool thing that we actually bought the company, and we're now incorporating all of their features in our standard feature set. So one of the first ones to come out of that is the thing called the Spot Bid Advisor. You can find this pretty easily by Googling it, or the URL's here on the bottom of the screen. Ask me for the slides if you're interested. What this gives you is that for a particular, you can choose your bidding strategy from a bunch of simple bidding strategies here, and then choose the region that you're interested in. In this case, I've got it pointed to Ireland, which is near my home in London. So what you get out of this is you get some advice from the Spot Bid Advisor as to what the probability is of you being rescheduled or being preempted in this market at that bidding price for that instance type. And so this gives you the ability to surf through the entire spot market looking for the sweet spots that might actually really work very well for your code, for the 1 day run or the 10-hour run or the 1 week run or 1 month run that you have planned, right? And this is giving you some great advice, and then in the end, it's also telling you, giving you a probability estimate of how much money you're going to save. It's giving you an estimate of how much you are likely to save off the sticker price, because as the spot market works, it's your bid that actually determines your rank in the list of folks that we go looking to preempt if we're having to do so. But the actual price that you pay is typically much lower than that. So the spot price fluctuates, and the spot price could actually be well and truly lower than your bid price. It means that in that case, you're not paying your bid price, you're just paying no more than your bid price, right? So this is an interesting market. It's kind of a weird auction, but it's one that we think creates a good sense of fairness for everybody who's participating. As with anything in Amazon, if you can do it in the user interface in the web, you can actually do it from a command line perspective as well. And so we've given everybody API and programmatic access. This is just an example of a Python script that's interacting with the API to actually do that predictive analysis. And we make all of that code available on GitHub, so it's pretty easy to download. It gives you another ability to come up with slightly more devious and clever ways of exploiting our spot market, right? Which we entirely endorse and thoroughly encourage. Another product that's come out of that team and we've released just recently is a thing called Spot Fleet. So Spot Fleet is really where you're solving the equation, you're solving the uncertainty equation for a different variable this time. And what you're doing here is you're actually saying, I'm looking for a certain amount of CPU capacity or spot capacity, and I'm either willing to pay a certain price for it. I've got a fixed price that I want to pay. Go find me the maximum sustainable situation, or here's the sustainability orientation that I have. Go find me the cheapest price for this. Go work out how to get me the cheapest price for these resources. So what you do is you actually create this. You create this essentially this set of instructions in this JSON file format. You specify a weighting for the different types of instances you're looking for. Now that's your weighting. You could be just a perfectly linear weighting on the basis of just one weight per core, right? And then you actually go out and you suggest how much target capacity you want to get, right? And that's really this number up here. So I've weighted these at 4, 2, and 1, and now I want 20 units of capacity. Now if I could also put in different generations of CPU cores in here, right? I could have Ivy Bridge and Haswell cores mentioned in here, and if I was a floating point intensive code, I might actually weight those at about 2 to 1, right? Which is be a fair ratio between between the number of flops per tick on a Haswell versus on an Ivy Bridge. If I wanted to, if I was an integer heavy code, I probably wouldn't weight them all that differently at all. So this is a weighting that you put in on the basis of what you expect the performance of your code to do on these instances. Then you specify how much capacity you're looking for, and you send Spot Fleet out to orchestrate all of that for you, and it gets you those resources in the ideal pattern that you're looking for, at the best price. And so like I say, there's a lot of different strategies. So this is another tool and another way of actually getting the resources you want out of the spot market. And then just recently we've released a new one, yet another iteration on this. We like to iterate on new features all the time. So the latest one for the spot market are these things called spot blocks. So you put in your bid in the spot market, and you can see a standard, this is a command line version of a bid getting put in, requesting a bunch of instances. But what you actually also specify is you specify this block duration. Now, if you specify the block duration, what you're saying is, I don't want to get preempted. I'm not willing to get preempted. My job is not sensitive, is way too sensitive to restarts. I can't checkpoint. I've got no capabilities of working around a preemption. So you specify how long you want it for. We will, if your bid comes into market, we will give you a fixed number of resources for a fixed period of time. But we'll give it to you at a slightly worse discount level than what Spot would normally give you. So instead of getting maybe 80 or 90% discount, you'll get maybe a 40% discount or a 50% discount off the sticker price. But you still come out, quite measurably cheaper. It works for workloads up to, I think, a maximum of 6 hours, but you get a flat hourly price out of that that's very predictable, and you don't get preempted, right? So you either receive the resources or you don't. That's the nature of the spot market. But in this case, this is a much easier and more predictable outcome. So now I should also mention, before I move on, that one of the other aspects of this kind of market, if you are going to get preempted, your jobs actually get a 2-minute warning. So we actually flip a metadata bit on an instance that you can see, and when that flips, it means that you've got a 2-minute counter as countdown has started. And at the end of that 2 minutes, you'll get preempted. Your instance will get shut down, and somebody else will move into that slot. This is a kind of environment where you can actually do a checkpoint quite effectively at that stage. And so this is not doing a checkpoint in advance and knowing, when you don't know that you're going to get killed, like in a normal checkpointing scenario on an HPC cluster where you don't know when death might happen, and so you checkpoint every 3 hours or every 2 hours or some such schedule like that. This is actually where you get told that you are going to die, so therefore you go and do a checkpoint, and so you're only really doing checkpoints when you need to, which is actually kind of a cool way to live. 2 minutes is more than enough to dump 32 gigs of memory core out to S3, so that's actually a pretty efficient way of checkpoint if you needed to, right? And a pretty cheap way of doing it. So you can actually get a pretty efficient operation like this. So this is actually there's a lot of neat things with this. Now the big upshots of all of these things, and this is Scico Computing exercises this every day and demonstrates this to their customers every day, is that when you're only paying for the bits that you're using and you're doing it in a really efficient way like this, you've got resources and money left over. And so there's a lot of things you can do with that. You could buy more compute. You could go larger and actually just analyze more data, more complex data sets, or a finer grained model of what you're trying to simulate. Those are all good things. Or you could actually spend some money on some other things other than a computer. I know that may shock a few people at this event, but if you're actually trying to push science forward, sometimes actually spending some money on a scientist or a spectrometer is actually a better way to contribute to the speed of the science than buying more computers. And then, of course, the last thing is never underestimate the importance of chocolate, so you could just spend some money on chocolate. Chocolate actually makes contributions to scientific progress every day. Now, Novartis and Scico did this experiment a couple of years ago. They got some really good numbers out of this. They actually ran a compound screening workload where they screened, I think it was 10 million compounds they screened. They did this on 87,000 cores that they scavenged in the spot market. Now, 87,000 cores in today's money, that's about, I think it's around about 3 petaflops. 87,000 cores of Haswell will give you around about a 3 petaflop supercomputer. So this is really getting access to a thing that's a huge national supercomputing facility. You're getting access to it. They actually bought these cores on the spot market for about $4,200. So this really is you really can, with this, put petaflops in the hands of postdocs or other scientists, and you could do some really awesome workloads with this. And this is just an awesome example, being able to do really big scale for the short periods of time where you really want to, so you can get away and do your analysis for the next year and sift through the results and figure out what discoveries you've made. So with that, I'll end, but if there's any questions, if anybody's got any observations, or more to the point, suggestions to us about how we can make this stuff better for you, please come and see me. Very happy to talk all the time and understand what our customers may be looking for that we're not delivering them yet, because that's actually our biggest mission. So with that, thank you, and if there's any questions, come and see me.